Excellent. Thank you for having me. We'll give you a little feel for what the Watson system actually is and why it's actually very important. As everyone has seen probably in the room, or at least a percentage of the folks in the room, that started actually very early on in the careers with general purpose machines. Really, they were looking at formulas. We were using Fortran in those days and COBOL, things like that. And we got to the 80s and we actually made a huge step forward when we started thinking about artificial intelligence, where it really could go. And clearly everyone has seen movies like 2001 where the machine was talking, or robots where the robot actually could respond to you and actually could think on his own. Watson is not that kind of machine. Watson actually is a reasoning machine, okay? It actually can learn from things that we allow it to ingest, learn from relationships, and then move forward. And it's actually brought forth at this point in time because there's been a huge collision of a few things. And it was actually brought forth by a huge collision. And that collision actually was Moore's Law from Intel. It was actually big data. If you think about how much data we have, ingesting that on machines, as well as it's all about analytics. And then how do we actually keep the content in one or more places? So this is actually what brought us there. If you actually look at the research project that brought you Watson, okay, this was not, well, most folks said, well, it only went from 2006 to 2010. Well, the reality is the researchers, some of them in that group, had been working in the area of natural language processing and artificial intelligence for 30 years. Actually, some of them took courses in AI and Lisp and Prolog when I did. Give you my age too. As we march forward, everyone probably in the audience is saying, why did IBM care about Jeopardy? Jeopardy was actually a milestone that we actually reached. Okay, we actually could take in a question in a very open domain, and we could actually then give someone an answer that we were confident in. Very key point was to get that circle, if you want to think of it. Now, the actual circle really comes down to we could understand natural speech, albeit English, and we can come back to that in a bit. And then we could generate some hypothesis on what we believe the question is. And let's be very clear here. Generate hundreds of hypotheses on what that is. Then the next piece of this is we can actually look for evidence and then deeper evidence and then actually come out with the answer to the question, or what we think will be the answer to the question. And then if we got it right, life is good. If we got it wrong, let's learn from our mistakes. And that really is the loop that we went through with Watson. So I'm going to actually give you guys a demo. This is not a Watson machine per se that played Jeopardy. This is a Watson machine that's actually in our test lab. It's not the Jeopardy machine that had 20 terabytes of information, from everything from Wikipedia to the New York Times to encyclopedias to various taxonomies they built into it. This is a machine that the only thing it actually does is we make sure that our internal pipeline works. So I only can answer certain questions. And those questions actually, in some state, are actually in Wikipedia. But the problem we have with answering those questions actually is we can't be very confident on the answers. And the reason we can't be confident is because we only have one source. Who knows if Wikipedia is right? Well, let's not go there. But who knows if it's actually correct? But I'm going to actually give you 5 questions that I actually I'll let you guys play later. We'll start from the bottom up. It doesn't really matter what order. Okay? A pretty complex question, actually. There we go. So what we actually did was, and I'll read you the whole question. If it was on a larger display, I could tell you. But basically, we're looking for an animal that actually has two slightly different shells. Okay? And basically, looking at the difference between these two. There actually has to look at this point in the case of analytics. The question is, a prawn looks like this saltwater animal, but the two have slightly different shells, and the prawn doesn't brood eggs. Not a very easy question. I'll be weighed down by the end of the afternoon. So let's look at two things. Well, we can only pray this works now, okay? We actually looking good because we actually have a performance indicator now if something's happening. But what I actually had to do just now, because I needed a much wider display, is we actually have Watson buried in IBM behind 3 firewalls. Not per se because Watson is, needs to be behind 3, but that is the way our security people really believe it needs to be locked down in our labs. So you'll see right now, we actually have the answer to that question, albeit it's called shrimp. Okay, so we got one question right. That's a goodness. Now, I actually would like one of you guys in the audience to give me this answer to this question. Wait till I tell you. What country has the largest solar energy dish? Country is, well, Australia is a country. Well, we'll see if we get this right then. Because what we're going to do is actually look at all the word searches along the way. Or we could actually crash, either one. What's actually happening now is the first thing we're going to look at is, when we pull the thing apart, is largest solar energy dish. Because we've looked at actually the subject, verb, and predicate. Sorry? Well, it's actually, you're all wrong. It's Israel. And it's actually in the Negev. Okay? Now, we can get some evidence to that effect. Okay? But here's a good example of, I was surprised too when I started thinking of this. So I actually looked this up in a very different way because I was looking at what countries in the world are very much into solar energy. And that actually led me to this one question. Another reasonable question is, well, you guys should know this one too. Absolutely. That was actually a secondary article that we found. Yeah, the first top of it is the first piece of evidence we used, and then after that we actually have deeper evidence. Let's see, are we doing anything? Okay, so this, here's another question. Now, clearly I could sit here all day and drop questions into the machine for you, but really what I'm focused on is showing you one thing. We actually looked at creating this open-ended answering machine. Two things are really important about it. The first thing is I actually have to ingest information that actually will allow me to search for those answers. During the ingestion phase, I look for three things. I look for how the sentence actually is composed, and it's always composed typically of a subject, a verb, and object or objects. As I look at this and I ingest more and more information, I actually see, and we do this during the ingestion phase, how actually these sentences actually all fit together and what links in with what. So that actually allows me to figure out in a very quick way and build more confidence. By the way, the answer to this question was Israel too, by the way. It isn't a mistake. So I think you guys got the idea of what I'm doing. I don't think I need to go through every one of these that I've got. But what's more importantly is that was the starting piece of where we were with Watson. Because it allowed us to build a machine that actually could take in language, in this case only English, and then it could allow us to actually give you an answer. Once we searched an incredibly large corpus. In this case, it actually was 20 terabytes. Here's a use case that is one of the ones we're actually working on today. A specific client of a financial institution basically is looking for pharma companies that focus in on CETP drugs. And the question you got to ask yourself first is, this is pretty simple. We absolutely can do a search using your favorite search engine on CETP. We'll end up with pharma companies as well as research, and life will be good. Okay? Well, let's just say we found 4. Okay? And at this point, we found 4, and we're looking at the quality of them, their names. First step we have to start looking at is from a business. Remember, this is a Wall Street firm, or a London firm, or a Tel Aviv firm, or etc. We're looking at who's got earnings potential. The first company actually has a failure. Not good. The second one actually has started phase 3 trials on human beings. And then basically the third is in phase 2, and the fourth is in actually phase 1. So clearly we're at a point right now where you can actually see us start looking at building confidence. Next step in this is let's look at the expenses. Since these are all startup pharma companies who are doing it, they have lots of expenses. They really don't have any profits. But we can actually start looking at profits and loss by, do they actually have any litigation pending against them? Okay, and that's what we just did. We found out that Acme actually had a suit that was just thrown out, and that Farmer actually just laid off some major number of employees. So we get a feeling of the climate of these companies. Next step in this that we put together actually talks to job creation. Are any of these companies actually hiring or firing? Okay? Very key point. Acme actually has 260 jobs listed. Okay? Where are they listed? They're listed on a website. I've just crawled the website and I've ingested the material. That's how I got the information. And the other ones had minor and major layoffs. So I'm now building a feeling of who's the best company, and it actually is the Acme company. And then last but not least, we actually look at, is there a pipeline to the field? Can these guys get the material out, the drug out? And you find out that the first company also actually has opened a new plant. Last but not least, we actually start looking at go-to-market strategy, of which they don't have a go-to-market strategy. That's pretty good. But if you think about how we started off, they were actually not your number 1 candidate. Okay? They end up as the number 1 candidate because we looked at multiple facets of the company. And the way we looked at them is we actually kept going through and all of the information we ingested and then built this out. Now, how did this all start on the beginning? What was the original question? I'll give you show you a brief movie and then come back to that example. I think we'll pick this one. Of course, we don't have sound. You do?
It's going to change how we interface with information.
People are going to ask, how did it do that? How did it accomplish this task, which before we thought only humans could ever hope to do?
David Hume held this view that sense and experience are the sole foundation of knowledge. Watson.
What is empiricism?
The other side.
Watson is a question-answering system. A question can be posed in natural language, and having read a whole bunch of information, data, documents, come up with a very precise answer to that question.
It's an information-seeking tool. Capable of understanding your question to make sure that you get what you want, and then delivers that content through a naturally flowing dialogue. Do you have one of those? I don't have one of those, right?
It's a human standing there with their carbon and water versus the computer with all of its silicon and its main memory and its disk.
After Germany invaded the Netherlands, this queen, her family, and cabinet fled to London. Maria.
Who is Beatrix?
No. Watson?
Who is Wilhelmina?
That is correct.
Humans communicate very fluently in natural language. And that's where computers struggle dramatically. And that's where we want to make them better.
This U.S. president negotiated the Treaty of Portsmouth, ending the Russo-Japanese War. Watson.
Who is Theodore Roosevelt?
Good for $800.
Jeopardy questions are tricky. They have puns in them, they have little jokes in them.
A famous red-coiffed clown, or just any incompetent fool. Watson.
Who is Bozo?
Nice. Good job, Watson.
I think we've gone from impressed to blown away.
This is really remarkable performance. And we know no computer system can come anywhere close to doing this question answering task.
Watson is the confirmed champion for this game.
But the reality is that being able to win a game at Jeopardy doesn't mean you completely conquered the language understanding test. Far from it.
In REM's It's the End of the World as We Know It, two of the men with the initials LB. Watson?
What is I Feel Fine?
Ooh, no.
The worst thing is if Watson just crashes in the middle of the game. That's what you don't want. But then the second worst thing is if you have some horrible bug where Watson starts getting everything wrong.
What are trousers?
No.
What is Cars Racing?
No.
What is Taxi to the Dark Side?
No.
What is artificial sweetening?
Come on now. No.
What is milk?
No. Very nice. Good for you.
This is triage. There's a million things to consider here. Our responsibility to the scientific community is to push this technology as hard as we possibly can, because when we get out there in public, what we're demonstrating is what is the state of the art? What can we really do?
It's limitless. The number of things you can potentially apply this to.
Watson, you have control.
What can I say after that? So you actually saw the whole Watson team that actually created it on screen, okay? With the guy with the beard, actually, is a guy named David Ferrucci, who's the principal investigator on the project. So where they left it right now is they gave the rest of IBM in software group a Watson to start with. And our job actually is to build a Watson that you saw in the financial case. Our job also is to start looking and working with them on really much larger problems than we can deal with ourselves, because we need to research. Watson's an English machine. It only knows English. It has a parser and a full NLP stack that only understands English semantics, as well as puns, metaphors, and everything else. Watson also needs to be extended to take care of situations like this, which we're doing right now. So our key focus right now in Watson is actually in healthcare. And here's a simple case where you have a person who's coming into a doctor, and basically she is been ill for a few days. And she's got a bunch of different symptoms. And, you know, first thing we need to do is extract those symptoms from basically the inbound record, or question, or paragraph in this case. So a bunch of different things here. Watson was really small sentences when it was answering Jeopardy. We're no longer doing small sentences. Okay? We actually have to do a whole bunch of new things. Not only look at sentences, and actually look at confidences in our answers, okay? But we also have to look at how do we actually restart the whole process when we think we made a mistake, or when we actually get more material from either the patient or the physician. So just looking at the symptoms, it would look like the person has influenza. However, when you start looking at the other pieces here, okay? The other pieces look at family history. Now, every physician does this in the back of their head, okay? And this family has a pretty interesting history of thyroid disease and cancers. which changes actually what you think are going to be the solutions. If we add in a bit more to this, okay, and you really start thinking about, you know, the patient's own history, okay, you're actually getting some more interesting things. The patient has autoimmune diseases, okay. More importantly, we find out that the patient's thyroid, which is an autoimmune disease, as well as the patient gets frequent UTIs. Add into that some more information, okay, like the patient's on the following drugs. Notice that from the past to the present, we actually added one more possible problem the patient might have, which is esophagitis from all the pills the patient actually is ingesting. But when you actually go in and add the last step, which is right there, you actually find out that the lab work actually says she has got a colony of E. coli that they've actually found in the lab through incubation. So clearly she has a UTI. So that's actually the input now to what Watson's dealing with. So when we actually look at, and I got a question earlier, how about other languages? We've actually just been able to deal with that right there. Okay, and by the way, this no longer takes 2.6 seconds. We actually have to iterate multiple times. Depending on what the issue is, it could take minutes. A doctor that I worked with very early on from Columbia University asked me one question. He says, if I buy a Watson, if I start the question at 8 o'clock in the morning, do you think it'll be done by 5? That's what he was looking for in terms of turnaround. The institutions that we're talking to right now, and one in particular that we're actually involved with, actually is looking for answers in the 30 to 60 seconds range. And, you know, we think we can get it. But this is a lot of path here to go down. Because a lot of what we have to start thinking about is managing the information flow. Okay? Where we actually had, let's say, 20 terabytes to play Jeopardy, we can have easily 2 or 3 times that just looking in medicine from ingesting journals from all over the world. And by the way, it's not only looking at ingesting those journals, but we also have to think about all the protocols for each of the institutions. Pretty much every country has their own protocols that they use. The institutions have their protocols, and then the doctors have their own favorites protocols. So each of these actually has to be put into it. Then we actually have to look at the patterns that we're going to find. And then we can actually optimize the machine to get much faster answers. So I'll summarize right here and say, you know, we're actually interested in working with Watson in a few environments. We're piloting right now in medicine. We actually worked with one customer who has call centers. And while every single person in the room probably used a call center, the biggest problem with call centers is misinformation that you actually get back from them. Because either they don't help you, or they help you too much and they erased everything that you just did. And when you actually understand the runnings of the call centers, at least the ones in the US, you find that the average attendant is there less than 3 months. So now you know why you have problems when you call it. So we actually looked at how do we basically help the attendant help the customer. So that actually means ingesting information about a lot of these devices. It's, let's say you call in with a camera problem. What kind of camera is it? Okay, digital or film? Okay, is the problem loading the film? Is the problem putting in the CF or SD card? Is the problem basically related to you dropped the camera? These are all questions that the attendant has to ask. But by the way, they don't ask them in that order on how you would actually figure this out. So we can actually help them and actually get them a more correct answer. However, the problem with call centers is they run on very slim margin. And a Watson actually takes a lot of work to actually get up, because you not only have to ingest the information, but the other side of it is you need to train the machine as to how to look for things. So we've got a lot of work cut out for ourselves. I actually showed you the web interface. We actually have other interfaces that we're working on. Those are the interfaces actually are all tablet or browser based, And the idea behind them is you actually can use them to give us information about you. For example, if you're coming into a doctor's office, what hurts? And how hard does it hurt, and where does it hurt? This is actually really useful when we actually look for differential diagnoses. Okay, the flip side of this is how do you basically want to weigh, as you saw in that patient case, her family history versus her own history versus looking actually at the lab tests. Clearly the lab tests put us over the edge on what was really wrong with her. But anywhere along the way, just think about the average sick elderly person who goes into an emergency room. What's going to happen is they'll come in with symptoms, it could be anything, and everyone will always think the worst, not the obvious. It's just the way, you know, things work. So the idea is to try to help everyone through this. It's going to take us time, but that's really what Watson is about. It's about looking at big problems, analyzing them, and trying to get basic solutions for everyone. But it's not, the machine won't be telling you it's absolutely this. The machine is going to inform you what it thinks. You as the human being really need to go that extra step and say, yeah, I think it is, or maybe it isn't. And that's actually key here. Because the human being is the arbiter here. They will make the final decision. Because machines make mistakes. You saw it make a mistake in that movie. That's it. Thank you very much. Thank you.
תודה רבה. תודה רבה לדויד בולוק, CTO, IBM. אמרתי משהו במסלול שלנו מקודם, אני רוצה להגיד את זה גם עכשיו לכולם. פרופסור ריי קורצווייל הוציא ספר על נקודת הסינגולריות, ושם הוא טען שאנחנו הולכים לקראת תחרות. יש טכנולוגיה ויש מודעות. הטכנולוגיה האנושית מנסה להשיג טכנולוגיה. המודעות האנושית מנסה להשיג את הטכנולוגיה. והשאלה היא האם אנחנו נפסיד בתחרות כשהטכנולוגיה תשיג מודעות. אנחנו בעצם נמצאים בנקודה הזאת. חבר'ה, אנחנו מאוד מאוד מודים לכם שנשארתם איתנו, הייתם איתנו. אל תשכחו, כנס חברים, כל מי שמעוניין, כל מי שחבר, בטדי 2, בדיוק מאחורנית. אנחנו מאוד מאוד מודים לכם שאתם כאן, ואנחנו פשוט מחכים לכם שם. תודה רבה. תראות שנה הבאה, או לפני.